Alright, we're going to continue our examination of polynomial functions. And one of the really cool things about polynomial functions is that their behavior, their end behavior, so that's when the function is either, the graph of the function is really far to the left or really far to the right, like far from zero. The end behavior is completely determined by two things: the sign of the leading coefficient and the degree of the polynomial. So I've broken this down into a table, and there are only 4 cases to consider. If your leading coefficient is positive and your degree is even, so an example of this might be like y equals 6x to the 4th plus 2x, then here the degree is 4 and the leading coefficient is 6, which is bigger than 0, then your function is always going to have the exact same behavior. It's going to act like x squared in a way. And by that I mean it's going to rise to the left and it's going to rise to the right. Okay? So this is for x being really negative or x being really positive. Okay? And then inside, inside this bubble, which is like when this is like x is relatively small, we don't know exactly what happens. It may go up or down a few times. We know it's going to be a function, but I'm just kind of drawing a dotted line and said we can't say exactly what's happening in here. I just know exactly what the end behavior is. All right. Now, if you had a positive coefficient but an odd degree, like y equals 5x to the 7th plus 3x plus 2, then I know that the function is going to fall to the left and it's going to rise to the right. So it acts like y equals x cubed. Right? Think of it being like y equals x cubed. So let me just write these down here. We're falling to the left and rising to the right. Whereas when you had even degree, you rise to the left and rise to the right. Okay. Now, if the coefficient is negative, like y equals, I don't know, negative 3x to the 8th plus 7x to the 5th. Okay. Here again, the only thing you need to look at is the negative 3. It's negative, and it's even degree. Then this is going to fall to the left and the right. So this is fall left, fall right. And again, we don't know exactly what's happening inside this bubble where x is close to 0. But it's going to look something like that. All right. Now the last case is when you have odd degree and you're negative. It'd be like y equals negative, I don't know, 3x cubed plus 1. Now here it's the mirror image, or the flip, upside down of the top right corner. So now we're going to fall to the right and we're going to rise to the left. Again, think of this as just flipping this top box up here, flipping it upside down. Okay, so now that you have this table, you should be able to predict the end behavior for any polynomial function. So here we have f of x is negative x cubed minus x squared plus 5x minus 3. And it's always a good idea to write down what your coefficients are here. So a sub 3 is negative 1, a sub 2 is negative 1, a sub 1 is 5, and a sub 0 is negative 3. So my leading coefficient is negative 1, and my degree is 3. So I have a negative leading coefficient and an odd degree, so I must be over here in this box. So that means that my end behavior is going to be something like this. So end behavior is to rise to the left and fall to the right.